everyone. So, today we're going to talk about a little bit about the basics of neural networks. Now, we're not talking about, we're going to use the example as our brain, but we're not actually talking about our brain's networks, neural networks, right? We're talking about machine learning. How do machines learn from going through processes, and how do we train it, right? So this is going to be a brief, very brief introduction to what neural networks are and how they work and what even is it, right? Now, what do neural networks do? They recognize patterns. So if we were to give ChatGPT, let's say ChatGPT because we all know what that is. ChatGPT, we give it a picture and it recognizes a picture of a cat. We give it a picture of a cat, it recognizes, oh, that's a cat. But how can a machine physically recognize that it's a cat? How does it even do that? I mean, it's pretty crazy, right? And what ChatGPT does, and it doesn't have to be only ChatGPT. It could be any type of machine, but it's an easy example. ChatGPT will make predictions on the future outputs, right? It could be weather, it could be stock prices, it could be the cat, for example. It's predicting using pixels, right? Using the picture we've given it. And neural networks also solve very complex problems, calculations, and formulas to then get to that output, right? So, using my example of my cat image, right? Let's cat picture. Okay. We have a little cute cat right here, and we want to input it into AI. We want to give it to ChatGPT and say, what is this? Okay. How does ChatGPT recognize it? How? So here we're inputting a picture of a cat, but the picture of a cat is made of multiple pixels, right? Pictures are made of pixels, and there's on the screen, you don't see them, but it's made of thousands and thousands, if not hundreds of thousands of pixels, however big your picture is. But we want to enter the raw data, so the raw image of those pixels, right? Now, behind that process of thinking, ChatGPT will go through a thinking process that finds patterns and extracts features, right? So, throughout all the training we've given it from society and from OpenAI, it's going to find similarities, comparisons, it's going to compare pixels to pixel over and over again, and that's a hidden layer, right? There's 3 layers. There's an input, the hidden, and the output. Okay, input. Input is the raw, equals the raw data. That's a picture of a cat, pixels of a cat. The hidden is what we don't see. We don't see what's going on. It's just the thinking process of the machine. It's a thinking process that finds patterns and extract features. Thinking process. We've understood that. It's very important. Now the third is output. After it's gone through the thinking process, we get an output. Now that output is a final calculation. Calc. And that is the final calculation, right? So how do we represent these 3 layers in a graph, or how do we represent it easily so we can actually visually see what's going on, right? So we want to write input is I, the hidden layer, and the output. In this example, we'll only use one output. It's just simpler, but you can have many different outputs, whatever you're asking the machine to do for you, right? So let's say we input x1 and x2. These are just variables. Sorry. x1, it's an index, and x2. Circles are not perfect, don't judge. And the hidden layer is this is where does all the thinking process. So it's going to compare a bunch of similar things, similar pixels, similar pictures, similar calculations, whatever you've inputted. So this is B1, B2, B3, B4, etc. These are just, we can do H. H is a perfect example because we have H. H1, H2, it's a hidden layer. Now these will connect, right? This will connect to this one, this will connect to this one, to this one, to this one. This might connect to this one, to this one. It might not connect to the middle one. These will connect to each other because they're networks. They're networks of these neural links that just work with each other to get the final output. Like I said, in this example, we're only going to have one output. So the hidden layer is a thinking process. This is where the machine learns and compares and thinks. It learns by what you're giving it and what it outputs. So it's also learning while you give it stuff to do. It's like a child. A child, you give a math problem. 1 plus 1 equals what? This is the raw data. Whoops. Raw data. Raw data is right here. Okay, raw data. Raw data is 1 plus 1 equals what? Now the thinking process of that child is in its brain, right? Or maybe he might think out loud, but it's happening in its brain, his brain, and he's constantly comparing and trying to think and resolve this calculation. Like he's using what he's learned in the past. So apple plus 1 apple equals 2 apples. He's going to compare apples, whatever he's thinking, and he says, oh, 2 apples. So it should equal 2. 1 plus 1 equals 2. And that is the output. So this is a raw data. The thinking process is what is in between these two. How you get the calculation, how do you resolve this? And the output is then what the question is equal to. And in this instance, it is 2. And that is the output. It's the same thing with machines. Machines are very similar to us. They're just like us. They have a brain, not a physical brain, but a computer brain. And this is how they think. And these hidden layers will then output this beautiful image of a cat saying, okay, it recognizes that this is a cat, or whatever you give it. If you give it a really complex equation, it'll go through all of this, compare all the equations, compare what it's learned, and give you an output. So you do 1 plus 1, it's the same thing. 1 plus 1 is the raw data, hidden layer is the thinking process, output is the answer. Simple. Now, let's get a little bit into the math, and it might be a little bit too much, honestly. We'll get a little bit into the math. So how are neural networks, okay, that's a Russian R, N. Okay, NN, neural networks, represented in math. So what is the formula to neural networks? Formula is represented by y sum of n is the wrong n again. Oh my god. N I equals 1 I times x I plus b. Now, what does this even mean? If you're watching this and you're still in algebra or geometry, I would probably not watch this video. I'd probably look at more of like the basic what neural networks are. But we're gonna get into a little bit of math for the advanced part, and we're not really gonna focus on this too much. But it's helpful to understand. Even if you don't know what this means yet, it's helpful to understand, right? So the output is the y. This equals to the output. Y equals to the output. Okay? Now the activation function is here. The activation function is what is multiplied by the actual function. So what does this mean and what does this mean, right? What is xi? What is all that? So these are the weights for each input. This is what the weight of that pixel is worth and that for that machine, right? Now B is the bias term. The bias term is kind of like the learning process behind it. And right here, this, I mean, if you're in calculus, or even algebra 2 maybe, you probably know exactly what this is. This is just the sum of, so you add up each weighted inputs for each n, right? Like I said, this was just for the more advanced people. I'm not going to get too much into that because it's pretty confusing if you have no idea what you're looking at. But let's do another example of a neural network and machine learning. We have two squares represented as x2 and x1. We have the neurons, or the hidden layer, right here. And then we have more neurons, learning process, thinking process, to then give the final beautiful output. So let's say all these squares, this can be represented by any type of variable you want. I'm just doing this as x1 and x2 because it's simple to understand, right? Now let's say half of this square is red and the other half is blue. I'm not going to color them completely. Now this top half is blue and this bottom half is red. These are just squares with colors. Simple to understand. I think a first grader would understand what this is. Now, let's split these neurons, and this part is red, the color red, and this part is blue. Right? Now, same thing for this. This part is blue. These are just random choices I chose. This part is blue, and this part is red. He compares these two images and finds a similar picture, right? So these are all connected. This is connected to this. This is connected to this. This is then connected to this, and then connected to this. So using the input we've given it, it'll try to find similarities in pictures, right? We're trying to get the output, we're trying to get a picture of something, okay? So we've given it this and this. Now the similar picture will be this half and this half. So they're similar because we have two very similar squares, right? Now remember, this is connected to this. That means it's connected to this, and this is connected to this, and this is connected to this using links, which then outputs a picture. So these are neurons, and these are neurons. This is, okay, this is a thinking process, right? This is where it's comparing things, putting things in similar ways. And now, after comparing these two, it might say, okay, I want this part, so it's not exactly half, to be blue. And I want this part, remember, it's not exactly half, just because it's comparing, finding ways to find the best exact similarity, the best prediction of that similarity. And then says that this part, just this part, is red, and the rest is blue. After the machine uses the neuron and the links to connect to each other and to think about the best output, so the best prediction of that output, it will then give us an output, right? Remember, this is the basics, okay? So then the output will then be blue, then be that half of this is blue and half of this is red, because it's compared this one to this one, this one to this one, this square to this square, this square to this square, this square to this square, etc., etc. It compares every single square, finds the best prediction for the output, and then gives us an output. So we started from these two raw data, so raw data, these two squares that we've colored in. We've given it into the machine. We gave it to the machine and said, okay, find me similar square or find the prediction. And now the output is our beautiful picture of half and half. Now that's the very simple way of representing what neural networks are, right? Now neural networks and machine learning specifically are very, 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 very more complex. It's much more complex. You just have to think of this probably times millions and millions and millions and millions of times, right? But we don't see that. This is all in servers, and it's just written down in code. We don't actually visualize this. We just visualize the output or the raw data. We don't see the hidden layer. That's why it's hidden, because we don't know what it's doing behind that thinking process. Now, unless you're actually coding the machine, you can actually see how it's thinking, how it's calculating things. But the average user of that machine is not going to see that. They're not going to go, and they probably won't even care about that. So this is how it's represented, remember? Now, I know the math is a little bit confusing. I'm going to make another video on what exactly this even means, but I just wanted to shoot it out there and say this was the formula for neural networks and for the output of a neural network, right? So just to make you see that it does get complicated very quick. And remember, this is still on like baby level. This is like even more baby level. I mean, but it doesn't matter. Remember, we all start somewhere. That's why I'm the simplified tutor. I make things that are hard simple. So this is lesson 1 of neural networks. We're going to do another lesson on the math behind neural networks. Thank you.